Hi, it's Geometry, Chapter 5.6. We're going to investigate inequalities in one triangle. So we're going to cover all these properties and theorems. Let's move on. So the comparison property of inequality, if we assume that C is positive, then, and I'm just throwing that A is equal to B plus C, that's a given. And then if you subtract C from one side, remember, C is a positive value, so we're subtracting it from one side. Obviously, now this side is going to be smaller than that left-hand side with the letter A. So A is going to be bigger than B. Well, that's pretty basic, but let's double-check with some numbers. So I arbitrarily threw, let's see, A is equal to B plus C. So I said that A is 7, B is 5, and C is 2. So A is equal to 5 plus 2. Yeah. And if you subtract the 2 from one side, then obviously 7 is bigger than 5. So 7 is bigger than 5, 7 is bigger than 2, so A is bigger than B, and A is bigger than the value of C. Okay? Okay. We're going to apply that now to a triangle with an exterior angle and two remote interior angles. So we're supposed to remember from the past that this angle here, this exterior angle, is equal to the sum of the remote interiors. Now, just in case you don't remember that, I threw some numbers in there to try to get you to re-remember what we learned before. So I just arbitrarily put a 60 here in place for a measurement of angle 2 and 80 for the measurement of angle 3. Because the sum of the interior angles of a triangle is 180 degrees, so if you take those two values and subtract it from 180, this value for this missing angle is 40. And there's a linear pair, so if you take 40 and subtract it from 180, then this exterior angle is 140. And then you should notice that this 140 is equal to the sum of 60 plus 80. Yeah. So let's put that into this mess over here. There's a 140 there. Here's a 60. There's an 80. And what this theorem is really saying is that if you take 60 plus 80 is equal to 140, well, if you look at each of those individually, 60 is less than 140, and 80 is less than 140. Pretty straightforward. Okay, let's keep going on. Theorem 5.10 is that if you numerically know the value of this length of this side, and this one over here, and this one's a big unknown, but what we can do is, if you look at this side here, this is longer than that side there. So we can do a comparison of the value of the numeric value of the measures of the opposing angles. So here, whoops, if we have this blue line here for AC, and follow that across to there for angle B, and then take this shorter side 5 and follow that across to this opposing angle C, then we can make the comparison that since this side is longer, then this angle here, angle B, has to be larger in measure than that angle C. And you don't know how A matches up in here because you don't have a value for the length of this side BC. But if I gave you numeric values for all three, then, well, the shortest side here is AB. So therefore C is the smallest measure in an angle there. BC is the next largest side, so follow that across. There you go. Angle A has got to be the next one up in size. And then this is the largest side here, so follow this across. Angle B has got to be the largest angle, which makes sense. Look, C, A, and B. Look, that's what I wrote right there. Okay. Now, the corollary of that is true. If you know the measures of the angles, then you can do some comparisons with the opposing sides. So here, angle C is the smallest value, and follow this across like a flashlight, right there. AB has to be the shortest side, well, the shorter of the two sides given here with these two angles. And then this angle is larger, so follow that across. AC has to be larger than AB. Now, this missing side, we can figure that out, because if you take these two and add them up and subtract them from 180, then, let's go to the next page, then that missing side is 60. Well, now we can pull it all together then. This is the smallest angle, so follow that across. AB is going to be the shortest side. This 60 is the next one up in size for angles, so follow that across. BC is the next largest side of the triangle, and then the largest angle here is 81.8, so follow that across there from B. AC has to be the longest side. Okay. Now, triangle inequality theorem says that the sum of the lengths of any two sides of the triangle has to be greater than the remaining third side. And then say that the sum of the lengths of the two shortest sides is greater than the length of the longest third side. Let's look at how that works out. So, look, I have a triangle here, and I have one side here is 5, and this other side here is 8. How long can this side be, this BC? Well, yeah, I made a video for this. Let's see if it plays. That's being a pain. Let's go to the shockwave file. So this is already going. Now look at this. As this slips down, look. When it's 13, it's a straight line. It's not a triangle anymore. So you can't say the sum of those two sides add together to create this BC. Okay, this is going to repeat it again because it was a shockwave file and I just jumped into where it left off the last time. Oh well. Anyway, see, look, it's going to keep on going. Look. So BC, for it to be a triangle, has to be smaller than the sum of those two sides. It can be 12.99999, but it can't be 13. Now, as it folds over here, look at the difference between 5 and 8. See, this side here, it can't become 3. The moment it becomes 3, it's no longer a triangle. But it could be 3.01. Cool video, huh? So I wrote this out neater, like for notes. A still frame here. See, look, I grabbed that point B and set that out there. See, this side BC can be up to the addition of the two shorter sides, but not including that value. It's got to be just short of that. Okay, and likewise in the next frame. So I took this point B here, and if you bring this around here so that now we have AB almost overlapping with AC, if you take the difference between the values of 8 and 5, you're going to get 3 for the difference. But if you put the value of 3 there, then this is a straight line. It is not a triangle, which means when you bring that point up, see, BC is going to be a tiny bit longer here. Well, it can be quite a bit longer. But what I'm trying to describe is that this length for BC can be just a little bit larger than 3, but can't be 3 itself. So it could be 3.00001, but it can't be 3. Right? So it's got to be between 3 and what we did on the previous page, 13. But it can't be either of those values. So let me write that. So BC, here, just sort of throw that in the middle here, has got to be between 13 and 3. Right? And that's it, I think. Yeah, thank you for watching.